Okay, so once again, good afternoon, and then we are going to continue to discuss topics on the circular function. So for this presentation, we are going to discuss illustrate the different circular functions and uses reference angles to find the exact values of the circular functions. Now, when we say circular functions, the concept of circular function, or also known as the trigonometric functions, I believe that the concept of the trigonometric functions were then discussed to you when you were in your grade 9. Okay, so katong right triangle trigonometric functions, katong sine, cosine, tangent, cotangent, cosecant, and secant. Okay, so the trigonometric functions some of the trigonometric functions actually are expressed in radian measures. Okay, and then calculated by the length and the coordinates of the terminal point of the arc on the unit circle. Okay, so although that it is said here that we are using radian measures in terms of its central angle in the unit circle, but in some convention, especially sa kuha, I usually convert the radian measures to degrees because I am quite familiar with the degrees rather than the radian. So that's why on the previous presentations that we have the conversions of angle measures from degrees to radian and radian to degrees. Okay, circular functions are functions whose domain and range corresponds to the measures of the angles with respect to the trigonometric functions. So take note here that the angles, okay, are actually expressed either in radian or in degrees. Okay, and then we are going to have the trigonometric functions. Okay, so the basic circular functions are the sine, the cosine, the tangent, and the reciprocal functions, which are the cosecant, the secant, and the cotangent, respectively. Okay, so if we are going to go back to the concept when you were in your so if we have a right triangle here, so assuming that this is a perfect right triangle, okay, so this is the right angle, and then of course this is our hypotenuse, okay, let's say h, and then this is our adjacent, and we have also here the opposite, let's say b. Okay, and this is the theta, the angle. In your grade 9, okay, I believe that you are quite familiar with these mnemonics. You have the soka, toa, chushakaw. Okay, so which stands for the sine theta is equal to the opposite over the hypotenuse, and then in ka, that is the cosine theta, that's equal to the adjacent over the hypotenuse, and then the tangent, the toa, okay, the tangent theta is equal to opposite over adjacent. Okay, and then we also have the reciprocal. So since we are talking about reciprocal, this means that the reciprocal of sine theta is the cosecant. So since reciprocal, we're just going to interchange the numerator and denominator respectively. So instead that we have opposite over hypotenuse for the sine, we have hypotenuse over the opposite side. And then for the secant theta, we have the hypotenuse over the adjacent. And then for the cotangent theta, we have the adjacent over the opposite. Now, let's try to form the right triangle with respect to our unit circle. Now, if we have a Cartesian plane here, and this is 1 unit from the origin, therefore this would be our unit circle, assuming that is a perfect circle. Okay, so if we are going to draw, okay, uh, a radius not in the quadrant, so something like this one. The theta that we are referring to here is this reference angle. Okay. Okay, so in the previous presentations that we had, we already computed, okay, some of the coordinates of the unit circles. Okay, some of the coordinates of the points on the unit circle. So let's say we are going to, okay, zoom in this right triangle. So parang meron na tayong ganito. And this would be our theta to right angle. So this right triangle is this one. Okay, and then since this is a unit circle, then the hypotenuse would be 1. The length of the hypotenuse is 1. So if we go back to our mnemonics, the Sokotowa Chushakaw, since our opposite and our sine theta is opposite over hypotenuse, therefore remember that the opposite of the angle theta here is this one. And this length corresponds to the, remember that we have point here. We have x, y. The length of this side of right triangle here is actually the y coordinates. Okay, so you have y. Okay, and then the hypotenuse is 1. So that is over 1. Therefore, sine theta is always the y coordinate of the point. Okay. Now, let's have the cosine theta. So the adjacent over the hypotenuse. Okay. In the adjacent over hypotenuse here, let's go back to this right triangle here. The adjacent of our angle, which is theta, is this one. And this length of right triangle here is represented by our y, our x rather. So therefore, the adjacent here is our x, and then our hypotenuse is 1. So you have over 1. Therefore, the cosine theta is our x coordinate. Okay. For the tangent, we have the opposite over the adjacent. So we have our opposite is y and our adjacent is x. Okay, let's continue. So our opposite, okay, this is x. The opposite side of the angle is y over the adjacent, which is the x. Okay, and then here we're just going to have the reciprocal of this one. So you have 1 over y, here 1 over x, and here we have x over y. So in other words, sine theta or sine angle is equal to y. Cosine theta or cosine angle is equal to x, and our tangent theta is equal to y over x. And for the reciprocal of these three trigonometric functions, then we have the cosecant theta, is is equal to 1 over y, and then we have the the secant theta is equal to 1 over x. Okay, let's continue. And then we have cotangent theta is equal to x over y. So these are the basic trigonometric functions that we have to consider. Okay, we are going to use these concepts for the entire trigonometric functions topic. Okay, so let's have an example. Okay, find the values of the six circular functions of the theta given that the terminal point P is P with the coordinates negative square root of 2 over 2, square root of 2 over 2. Okay, now for our solution, so we have the sine theta is equal to, remember that our sine theta is our y. The cosine theta is equal to x. The tangent theta, okay, the opposite, we have y over x. And then for our reciprocal, we have the cosecant theta. Oh. Okay, we have the cosecant theta is equal to 1 over y. Secant theta is equal to 1 over x. And our cotangent theta is equal to x over y. And since we have the point negative 2, negative square root of 2 over 2, square root of 2 over 2, therefore, we could say that our x is equal to negative square root of 2 over 2. And our y is equal to square root of 2 over 2. So we are just going to substitute these values to our trigonometric functions. So in other words, our sine theta is equal to negative square root of 2 over 2. For the cosine theta is equal to our y, we have square root of 2 over 2. For the tangent theta, we have the y over x. So that is, our y is negative square root of 2 over 2 over square root of 2 over 2, which is our x. So since we have the same value of our numerator and denominator, but they differ into the sign, and if we have the same numerator and denominator, that's equal to 1. And then the quotient of opposite sign is negative. Therefore, the tangent theta here is negative 1. Now, for our cosine, not the cosine, the cosecant rather. For the cosecant theta, we have 1 over negative square root of 2 over 2. Okay, since it is the reciprocal of this one. Okay, we have to rationalize the denominator here. So you have to multiply, okay, here by square root of, okay, so since y man siya, so dapat this is positive and this one would be negative. Okay, thank you for your correction. So this must be negative, this would be negative. Oh, ayan. And then the other one must be also positive. So here. Okay. So we have to, since we have ang mas maganda dito, instead that we have 1 over square root of 2 over 2 here, okay, since we're just going to reciprocal this one, to make this 1, the reciprocal, yan na lang yung gagamitin natin. So, instead, that one. Okay. So, the reciprocal of this one is 2 over square root of 2. Okay. We have to get the rationalize the denominator. So, we have to multiply the numerator and denominator by square root of 2. So, here, we have 2 times the square root of 2 is 2 square root of 2 over square root of 2 times the square root of 2 is 2. Okay, so we have the same numerator and denominator, so we have to divide that out. So that's equal to square root of 2. So in other words, the cosecant theta is equal to square root of 2. For the cosine theta, not the secant theta rather, is just the reciprocal of this one. So you have the reciprocal is 2 over square root of 2. So since we have the what we call this one, radical in the denominator, we can rationalize the denominator by multiplying the numerator and denominator by square root of 2 over square root of 2. So here we have negative 2 times the square root of 2 is negative 2 square root of 2 over negative square root of 2 times the square root of 2 is 2. So in other words, okay, divide out, then we have negative square root of 2. Here, the tangent, the cotangent rather, dito na lang, theta, is just the reciprocal of negative 1. And the reciprocal of negative 1 is just negative 1. Therefore, the 6 circular functions, theta, okay, given the point negative square root of 2 over 2 square root of 2, or, okay, we have sine theta is equal to square root of 2 over 2, cosine theta is equal to negative square root of 2 over 2, cotangent theta is equal to negative 1, tangent theta is equal to negative 1, the cotangent theta is negative 1 also, the secant theta is a negative square root of 2, and the cosecant theta is equal to to square root of 2. So let's have another example. Give the 6 circular functions of an angle theta generated by an arc whose length is 5 pi over 6. Okay, if in this example, the given is not a point, but an arc length. But remember in our previous discussion that the central angle is equal to its subtended arc. So in other words, if the arc length is equal to 5 pi over 6, therefore, the angle, the central angle, whose that arc is being subtended to, is equal to 5 pi over 6. So, para mas makita natin, or we can really visualize the number here, we're going to convert the radian, because 5 pi over 6 is in terms of radian. So we are going to convert the radian into what we call this one, degrees. Okay. Because personally, in my opinion, it's better to visualize the angle if it is expressed or converted into degrees. So since we have 5 pi over 6, and then we are going to convert this one into degrees, then we have multiply by the conversion factor, we have 180 over pi. So here, na-divide out na ang pi. So what we have here is equal to 5 times 180 over 6. And remember that 5 times 180 is equal to 900. Okay, 900 over 6. And 900 divided by 6 is equal to 150. So in other words, okay, the 150 degrees. So in other words, if we are going to draw, okay, a unit circle here. Okay, imagine this is a unit circle. Okay, and we have an arc length of 150 degrees. Therefore, from our terminal side going to the initial side rather, going to the terminal side, so somewhere here, this would be the angle. So we have the 150. So the terminal side lies on the second quadrant, and the reference angle of this one is 30 degrees, remember? So since this would be the point, then from the previous discussion that we had, we can actually, okay, determine now the point, okay, of the given the coordinates of this given point. Okay, so remember that the this point has the nature of negative, positive. So the x here is negative, the y is positive. Okay, so here, because we have 30 degrees, therefore from the previous discussions that we had, okay, we have negative square root of 3 over 2, and then we have 1/2. Okay, diba? That would be this is actually what we have, what you had in your previous week. So in other words, our x here is negative square root of 3 over 2, and our y is equal to 1/2. Okay, now from this point, then we can now generate the six circular functions. If you have scientific calculators there, actually you can use your scientific calculator to verify if the answer is correct. Okay, now, so we have cosine theta, but instead of theta, we can actually have cosine 150 degrees. Okay, the cosine 150 degrees is our x. So we have negative square root of 3 over 2. The sine, okay, 150 degrees is equal to 1/2. Okay, and then our tangent 150 degrees is equal to y over x. So our y is 1/2, and our x is negative square root of 3 over 2. Okay, so in this case, we are going to multiply the reciprocal of this one. Okay, so what we have is 1/2 times 2 over negative square root of 3. Okay, so divide out, what we have here is negative 1 over square root of 3. And since this is in the radical, we can rationalize this one. So square root of 3 over square root of 3. So what we have here is actually negative square root of 3 over 3. So that's our tangent. So for the cosecant, theta is the reciprocal of this one. So that is 2 over negative square root of 3. So we have to get the rationalize the denominator. So you have square root of 3 over square root of 3. And what we have here is, we have the negative 2 square root of 3 over 3. Okay. And then for the secant, theta is the reciprocal of this one. So the reciprocal of 1/2 is 2. And then the tangent theta, cotangent rather, theta is actually, we can make this as 150. So you have reciprocal of this one, then you have 3, negative 3 over square root of 3, and then get the rationalize the denominator. Square root of 3 over square root of 3. What we have now is negative 3 square root of 3 over 3. Okay, and then we can now divide out the numerator and denominator. Then what we have would be negative square root of 3. Okay, for convention, let's try to rewrite the theta here by 150 degrees. Okay, so in other words, the 6 circular functions whose arc length is 5 pi over 6, we have cosine 150 degrees or cosine 5 pi over 6, they are just the same, is equal to negative square root of 3 over 2. The sine 150 degrees is 1/2. The tangent 150 degrees is negative square root of 3 over 3. The cosine 150 degrees, not cosine, cosecant rather, the cosecant 150 degrees is equal to negative square root of negative 2 square root of 3 over 3. The secant 150 degrees is 2, and the cotangent 150 degrees is equal to negative square root of 3. Any questions? Okay, suppose S is a real number such that sine S is equal to negative 3 over 7 and secant S is less than 0. Find tangent S. So this is tangent S lang. Okay, now take note that our sine S, okay, in this case kasi we have negative 3 over 7, which is you cannot find this one in our unit circle. So in other words, this example is not a unit circle example. Okay, because if we can still remember on the coordinates that we had last week, okay, wala tayong negative 3 over 7. So in this case, we are going to treat this one as a right triangle. Okay, so for our solution, okay, sine S is equal to negative 3 over 7. Now take note that our sine S in the previous slides, okay, this is y over the radius or the hypotenuse. Okay, so in other words, if we are going to have a right triangle here, okay, so here it could be in the third quadrant or fourth quadrant kasi negative man siya. R cannot be negative because that's radius. Okay, so pagpalagay natin, let's treat this one as a whole number. Not a whole number, a positive number. So pag ganito siya, and this is our angle S, okay, sine is opposite over hypotenuse. So this is 3, this is 7. So since we have 3, we have 7, what would be the length of this side? Using the Pythagorean theorem, okay, let's say this is our A. A is equal to, ano ba? Okay, that's equal to the square root of c squared minus b squared. So you have the square root of 7 squared minus 3 squared. So that is the square root of 49 minus 9. Okay, so this is equal to square root of 40. Now, square root of 40 can be can be factored out using the square root of 4 times 10. Therefore, this is equal to 2 square root of 10. So our a here is 2 square root of 10. Now, since sine is equal to sine s is equal to negative 3 over 7, and then we have also the notion that the sine s must be less than 0. In other words, it must be negative. So since it is negative, so we are going to look for the negative cosine. Okay. So since we have negative cosine, okay, so cosine s is also negative because it's just a reciprocal. Okay, kasi not cosine s but it should be cosine theta. Okay, is less than 0, therefore it's a negative. We can now visualize that our sine s is negative, cosine s is negative. We can now visualize that that point, okay, lies on the negative, which is in the third quadrant. Okay, so negative ang ating x here. Okay, so if y is equal to 3, negative 3, our a here or our x here must be negative also kasi cosine s is negative. Okay, so nasa third quadrant. Okay, now for tangent s is equal to negative y over negative x. So remember that negative y over negative x is positive. So you have negative 3 over negative 2 square root of 3, square root of 10 rather. Then we have to multiply by square root of 10 over square root of 10. So here we could have 3 square root of 10 over 2 times square root of square root of 10 is, it must be 10 here. Okay, so it must be 3 square root of 10 over 20. So in other words, our tangent s is equal to 3 square root of 10 over 20. Okay, any questions? Find the reference angle of the following given angle in standard position. So I believe that is already discussed. Okay, so for our solution, it is better that we are going to visualize first our angle, which is the 204, and in a standard position, therefore the 204 lies in the third quadrant kasi we have here, kung we have Cartesian plane here, this is 90, this is 180, and this is 270, and 240 is less than 270, therefore it is in the third quadrant. So in other words, since it is in the this is in the third quadrant, then we could say that to find the reference angle of 204, we have to subtract 204 by 180. Okay, so for our solution, 204 rather. So for letter A, 204 minus 180 degrees. So 204 minus 180, that's equal to 24 degrees. So in other words, the uh, the reference angle, okay, of 204 is 24. For letter B, okay, we have to visualize that this 100 negative 150 degrees, okay, where is the terminal side of this negative 150? So if this is 90, this is negative 90 rather, and this is negative 180, okay, and then negative 150 is of course greater than negative 180. Therefore, it lies in the third quadrant. So, the reference angle, because we're referring to reference angle, and it's always positive, therefore, let's treat this one as, okay, let's treat this one as positive. Okay, so here, we have 180 minus 150. So here we have 30 degrees. In other words, so here, this is the negative 150 degrees. What remains here is 30 degrees to make a 180 degrees. So let's proceed. Find the values of the six circular function of theta whose terminal side is at 3 pi over 4. So 3 pi over 4 siya. So in this case, as what we have done in the previous presentation, we are going to convert that one into degrees. So to convert that one, then we have 3 pi over 4 multiplied by 180 over pi. So we can now divide out the pi. What we have is 180 times 3 over 4. 3 times 180 is equal to 540 over 4, which is equal to 135 degrees. Okay. Now, 135 degrees. Okay, in this case, 135 degrees, nasa second quadrant siya because it's less than 180 degrees. To illustrate more, para mas to visualize more, they are going to illustrate. So here, that is 90, and the half of the revolution is equal to 180. However, 135 is less than 180, therefore, somewhere here siya. Okay, so this is the 135. Now, what is the reference angle here? Okay, so what is this angle? What is the reference angle of 135? So, how much you should add to 135 to make it 180? So, in that case, that is 45 degrees. And 45 degrees in the second quadrant. Therefore, the nature of the points here, okay, the nature of the points here is we have positive, negative, positive rather. Negative, positive. And since this is in the second quadrant and the reference angle is 45 degrees, therefore the points here must be negative square root of 2 over 2, square root of 2 over 2. Okay. So, easy na lang siya. So, here, the sine 135 degrees is equal to the y. So, you have square root of 2 over 2. The cosine 135 is the x. So, you have negative square root of 2 over 2. The tangent 35, ganito na lang. Ang pang. So, this is tangent 35 degrees. So, here, we have the numerator and denominator. They're just the same number, but they differ in the sign. Therefore, klaro, -1 ito. Okay, because we have to divide only those numbers. And then, they are unlike sign, therefore -1. So here we have, okay, cosecant 135 degrees. Okay, so you have to get the reciprocal of this one. So you have 2 over square root of 2. And since naka-radical ang denominator, then we can now have the rationalization of the denominator. So we have to multiply square root of 2 over 2. So here you have 2 square root of 2 over this one. Square root of 2 times the square root of 2 is 2. Divide out the numerator and denominator. What we'll have is square root of 2. So here, for the secant 135 degrees, so you have this one, -2 over square root of 2. So we have to multiply by square root of 2 over square root of 2. But what will we have would be -2 square root of 2 over 2. Okay, because the product of square root of 2 times the square root of 2 is 2. Divide out the numerator and denominator. What we'll have would be negative square root of 2. Therefore, the secant 135 degrees is negative square root of 2. And for the cotangent 135, okay, the reciprocal of -1 is -1. So these are the 6 circular function of theta whose terminal side is at 3 pi over 4. Use reference angles to find the exact values of the 6 circular function given the function cotangent 1 at cotangent 210 degrees. Okay, since our theta is 210 degrees, so here we get the reference angle first of the 210. Okay, so this is less than 270, diba? So in other words, we have to subtract 200. We are going to nasa third quadrant kasi siya. So we have to subtract this one by 180. So for our solution, that is 210 minus 180 degrees. So that's equal to minus siya 30 degrees. And nasa third quadrant siya. So the nature, by the way, if we have to visualize the 210, ha? Okay, so since the angle 210 lies on the third quadrant and the nature of the points on the third quadrant is negative. Okay, so our x is negative and our y is also negative. And since it is 30 degrees, then we can now actually have the points from the previous discussions that we had, then the point, okay, in the unit circle whose central angle is 210 in the standard position must be negative square root of 3 over 2 negative 1/2. Okay, so in other words, our x must be negative square root of 3 over 2, and our y is negative 1/2. So we have cotangent 210. Okay. The other 5 na lang ang kukunin natin. Okay. So we have the sine 210 degrees is our y. Therefore, that's equal to negative 1 over 2. If you have calculators there, you can actually check. If you have scientific calculators, you can actually check that the sine 210 is equal to negative 1/2 or negative 0.5. Okay. For the cosine 210 degrees, okay, the exact value would be this one. So you have negative square root of 3 over 2. And for the tangent 210 degrees, that's equal to y over x. So you have negative 1/2 over negative square root of 3 over 2. So we can express that one like this one. Okay, the reciprocal of the denominator. So you have negative 2 over square root of 3. So divide out. And since they are both negative, okay, so you have 1 over square root of 3. So get the rationalize the denominator. So multiply square root of 3 over 3. Square root of 3 over square root of 3 rather. Then you have square root of 3 over 3. So that's the tangent 210. For the other two, okay, trigonometric functions, then you have the cosecant 210 is the reciprocal of this one. So that's negative 2. For the secant 210 is the reciprocal of this one. Then you have negative 2 over square root of 3. So multiply by the rationalize the denominator. So multiply square root of 3 over 3, square root of 3 rather. Then what we will have here is square root of negative 2 square root of 3 over 3. Okay. By the way, when we get our cotangent 210, reciprocal of this one, so you have 3 over square root of 3. Multiply by square root of 3 over 3, square root of 3 rather. Then what you will have here is 3 square root of 3 over 3. So divide out, you have square root of 3. So these are the 6 the exact values of circular function given that the function is cotangent 210. Okay, find the values of the other 5 circular functions if the sine theta is equal to 12 over 13 and lies at the second quadrant. So here, sine theta is equal to 12 over 13. So let's have to illustrate this one in a right triangle because 12 over 13 is not a unit circle. Okay. So let's treat this one as a right triangle. So sine theta is equal to 12 over 13. Remember that the sine is y over the hypotenuse or the radius. So in this case, let's draw a right triangle. And this is the theta. Sine is opposite over hypotenuse. So the opposite of theta is 12. Therefore, the hypotenuse is 13. So what is the length of this side? So using the Pythagorean theorem, let's make this side as a. Then we have a is equal to the square root of c squared minus b squared. So which equal to the square root of 13 squared minus 12 squared. So here, the square root of 13 squared, okay, is equal to 169 minus 12 squared is equal to 144. So 169 minus 144, that's equal to 25. Square root of 25. And square root of 25 is 5. So therefore, this is 5. Now take note that the theta lies on the second quadrant. Therefore, on the second quadrant, the nature of the points, okay, is negative, positive. Therefore, our x must be negative and our y must be positive. So in this case, our x here, okay, the opposite, okay, the x rather is the adjacent. So our x here is negative 5 and our y must be positive 12. So let's have the 5 circular functions. Okay. Here, we have already the sign. So we have the cosine theta is equal to x over the hypotenuse. So you have negative 5 over 13. Okay. The tangent theta would be 12 over negative 5. So that's why we have negative here. The cosecant theta is equal to, okay, the reciprocal of this one. So you have 13 over 12. The secant theta is the reciprocal of this one. So you have negative 13 over 5. And for our cotangent theta is the reciprocal of this one. So you have negative 5 over 12. So we have now the other 5 circular functions. If the sine theta is negative is 12 over 13 and lies in the second quadrant. And that's the end of the presentation.